Hello students, in this video I will explain deviation of real gases from ideal behavior. We have got ideal gas equation PV is equal to nRT, and this is meant only for the ideal gases, ideal gas, and the ideal gases do not exist in nature. Whatever gases are there in nature are called the real gases, and real gases do not obey this equation at all temperature and pressure. Therefore you have to go for new equation, and the equation derived is known as the van der Waal equation. Van der Waal equation, which means ideal behavior is not equal to real gas behavior, or the real gases deviate from the ideal behavior. Now why it is so? Because there are two wrong postulates in the kinetic molecular theory. That is, first one is, it says that there is no force of attraction between the molecule. No force of attraction between the molecule. Actually, there is a force of attraction between the two molecules in the gases. There is a second wrong postulate which says that volume of gas molecule is negligible compared to the total volume occupied by the gas. There are two wrong postulates which led to the wrong equation, that is the ideal gas equation. Now we have to rectify this one to get the new equation called the van der Waal equation. Real gas can deviate from the ideal behavior or can also approach the ideal behavior. Now let us see the real gas which shows ideal behavior at low temperature, low pressure and very high temperature and high temperature. Okay, so this you have to remember. Or real gas deviate from the ideal behavior at the higher pressure, high pressure and the low temperature Okay students, you have to remember this one. Clear? The ideal gas equation PV is equal to nRT meant only for ideal gas at all temperature pressure, but ideal gas do not exist. So we have got real gases in the nature. Now for real gas PV is not equal to RT, which means the left hand side is not equal to the right hand side. So what do? We'll take a ratio between the left hand side to the right hand side and we call it as the Z value. Okay, and this Z value is called as the compressivity factor, Z. What is this compressivity factor? It is the extent or deviation of real gas from the ideal behavior. Now this Z value can be equal to 1 because when PV is equal to nRT, so it becomes equal to 1. It can be greater than 1, it can be lesser than 1. Okay, let us see what the meaning of is equal to 1, greater than 1 and less than 1. When PV is equal to nRT, left hand side is equal to right hand side. When they are equal to each other, then the ratio is always equal to 1. And therefore Z is equal to 1 for all conditions of temperature and pressure, and is only for the ideal gas, not for the real gases. For real gases, that is far away from the unity. Unity means 1. Okay. So greater the departure of Z from unity, more is the deviation of the ideal behavior. Okay, or you can remember one example, H2 gas shows positive deviation at all pressures. Positive deviation means that is a greater than 1, and if that is a lesser than, it is called the negative deviation. Okay, now when there is a Z greater than 1, which is called the positive deviation, gases are less compressible, which means gases cannot be compressed easily. Suppose it is a less than 1, great, that is a negative deviation. It implies that gas can be easily compressible, can be converted into liquids easily. So instead of ideal gas equation P is nRT, we have got new equation for the real gases, van der Waal equation. It can be for 1 mole of the gas or the n mole of the gas. So I'll write now for 1 mole of the gas. So it is a P plus something, that is a divided by V square into V minus B is equal to RT for 1 mole of substance. That means PV is equal to RT for the ideal gas. Now instead of pressure we have got P plus A by V square. Instead of only volume we have got V minus P. Okay. Now I'll go for n moles of the gas. For the n moles of the gas we have got, I'll write here P plus A n square divided by V square into V minus Nb is equal to nRT for n mole of the gas. Suppose you substitute n is equal to 1 here, we'll get this equation back. Okay. So what are A and B here? A stand for A and B are the van der Waals constants here. Okay. P is the pressure, V is the volume, R is the ideal gas constant, T is the temperature, and N is the number of moles. Okay. Now let us find out what is the unit of A and B in the van der Waals equation. So we have got pressure term P plus A n square divided by V square. This is the pressure term. So this is the pressure term here, this also pressure term. Both the pressure terms are added up here. Okay, so let me take, this is the A n square divided by V square is nothing but the pressure term, correct? So the pressure term. Let me call this pressure as equal to, in terms of atmosphere taken. So let me take atmosphere. So we need to calculate what is the A. So A is equal to atmosphere. Then we have got volume square divided by n square. Therefore, the unit of A is equal to, it is the atmosphere. Let me write V square, volume in terms of liters. So it is a liter square divided by n stand for number of moles, n square. So it is a mole square. Okay, clear? Similarly, the units of B, we have got in the van der Waals equation V minus Nb term, correct, for the volume. So this is the volume term, this is also volume term. So let me take a Nb is equal to volume term. Okay. So Nb is equal to, let that volume be equal to in terms of liters. Okay. Therefore B is equal to liter divided by N is nothing but number of mole. So liter by mole it is. Correct? Right? Two very important significance of A value and the B value you have to remember. Here, the value of A is the indirect measure of the magnitude of the attractive forces between the molecules. Okay, magnitude of attractive forces. Greater the value of A, more easily liquefaction of the gas can occur. As the A value increases, gases can be liquefied easily. Next one, the value of B gives an idea about the effective size of the gas molecule. Greater the value of B, larger is the size of the molecule and smaller is the compressible volume, which means as the size of the molecule goes on increases, the gas cannot be liquefied easily. Clear? Students, real gas can be converted into ideal behavior at a particular pressure and the temperature at which the real gas can become ideal gas over appreciable pressure is called as the Boyle's temperature or the Boyle's point. Okay. So how to calculate that Boyle's temperature or Boyle's point? So TB, T stands for temperature, B stands for Boyle, is equal to, given by the formula, A constant from the van der Waals equation divided by ideal gas constant R into the van der Waals equation B. So A divided by RB you have to remember. Okay. Now, while we convert a gas into a liquid, we have to remember three important parameters. One is the critical temperature Tc, critical pressure Pc, and critical volume Vc. These are the very important factors, okay, to find out at what temperature, pressure, and volume gases can be converted into liquid form. Now, see the first one. The temperature above which gas cannot be liquefied. However, high pressure may be applied is called the critical temperature. So critical temperature is the maximum temperature at which gas can be liquefied. Above the temperature cannot be liquefied, but below the temperature anytime the gas can be liquefied. So there is a formula to calculate a critical temperature. Critical temperature is equal to, previously I got Boyle's point, that is A divided by RB. Now what you do is you multiply by 8 and 27 here. Clear? This is a formula to calculate the critical temperature for the given gas. What is this critical pressure now? It is a minimum pressure required to liquefy the gas at the critical temperature. It is called critical pressure. How to calculate critical pressure is given by the formula A divided by 27 B square. Okay, right? The last term about the critical volume. What is critical volume? It's a volume occupied by 1 mole of the gas at critical temperature and critical pressure. How to calculate critical volume? We have the formula Vc is equal to 3 times P. Okay, clear? Now let us see some Kcet previous year questions. Okay, Van der Waal equation for n mole of the gas. What you can do is you can pause the video, see the option student, and tell me the answer. Okay, you can take the answer in the paper. Okay, right? The answer for this question is, what is the Van der Waal equation for n moles of the gas? We have the formula P plus A n square divided by V square into V minus NB is equal to nRT, correct? Where A and B are the Van der Waals constant. Clear? So what is the answer? Answer is option number 1, correct? A gas deviates from ideal behavior at high pressure. You know this one, right? This can at high pressure, low temperature, real gas deviate from the ideal behavior. Okay, here they are given at high pressure because it's molecules. So what will happen when you apply the high pressure? When you apply the high pressure, molecules come closer to each other. When the molecule come closer to each other, what will happen? Okay, so find out the appropriate answer. Molecules coming closer means they should attract each other. So attractive forces become more at higher pressure. Clear? So the answer is option number 3. Attract one another. Question number 3. The statement that is not correct. Option 1. Compressivity factor measures deviation of real gas from ideal behavior. It is a true statement. Van der Waal constant A measures the extent of intermolecular attractive forces. Okay, that is also correct statement. Critical temperature, lowest temperature at which liquefaction of the gas first occurs. No. Critical temperature is the maximum temperature at which gas can be liquefied. Above that one, you cannot liquefy, but lower than that, at any temperature, you can liquefy the gas. So, option number 3 is a wrong statement, not correct. Option number 4, boil's point depends on the nature of the real gas. Correct. Okay. So, boil point is different for different gases. Okay. Right. So, answer is option number 3. Question number 4. Pressure of the real gases is less than that of the ideal gas, which means for ideal gas, pressure is more compared to the real gas. Now, what will happen in the case of real gases? Okay, what do you mean by pressure? Pressure is nothing but the gas molecules applying force on the wall of the container. Right? They hit the wall of the container and the pressure created. Pressure nothing but force divided by unit area. Correct? But whenever the real gases are there, real molecules are there, what will happen? There is attraction between the molecule. Whenever there is attraction between the molecule, okay, the speed with which it can collide the wall is less. Okay, therefore, pressure also becomes less. So, what could be the option, students? Okay, so the answer is the intermolecular force of attraction. Clear? Question number 5. For ideal gas, compressivity factor Z is equal to 1. Easiest question. Answer is option number 2. Right? Question number 6. 4 gases, P, Q, RS gases have almost same values of B. B values same. But their A values are in the order Q less than, R less than, S less than P. At a particular temperature, among the 4 gases, most easily liquefiable one is. Now, only A is varying. Okay? As the value of A increases, attractive forces between the molecule increases. Attractive force between the molecule increases. When the attractive force between the molecule increases, molecules come closer, right? When the molecule come closer, it is easy to compress the gas. That means the gases can be easily liquefiable. That means larger the value of A, easily gases can be liquefied. Easier is the liquefaction of the gases. So which has got the largest A value? That is the P as the largest A value, therefore P can be easily liquefiable. Okay, so the answer is option number 1, right? Students, like the videos, share the videos, and please do subscribe RD Chemistry YouTube channel as well as the Telegram channel. Thank you for watching.